We have easy problem today. It is a binary array, and we asked to calculate if any or all binary representation of prefixes is divisible by 5. So the result is true, false, and so on. So this is kind of easy problem if the range is small, but the range is 10 to the power of 5, and that means we can't represent this as int or even long. So because each position multiplies our number by 2, and it very quickly becomes out of range. So the solution to this problem is the property of modular division operator. What does it mean to produce all these numbers? We have to take the previous value, then we have to time multiply it by 2 plus the current value plus 1, and so on. That gives us equation like x times 1 plus 1 times 2 plus 1, and so on, plus 0. And each time we want to find if it is divisible by 5 with modular operation. So what we care about is that the sum of this is irrelevant of the actual value. We only care about what is left over, or the remainder. That means we can rewrite it like this: x divisible by 5 times 2 plus 1, then again modulo 5 times 2 plus 1, and so on. And that gives us only range of 0 up to 5. So this is a solution. Just keep one variable and multiply it by 2 plus the current, and then the result. Let's look at other people's solutions. Yes, this is kind of solution. It's all the same. I would be interested if this can be represented by a number. I don't know, maybe in the base of 5. I wasn't able to convert this because some properties of this mathematics is not very native for me. But if you can convert to the base 5, you can just look at the last digit if it's 0. Basically, you actually have this like the last is 0 or not. I'm not sure if this is the actual conversion to the base 5. Can we look at it? Like, let's try to make it work. Is this a base 5? Zero, 1, 3. One is 1 and 1, 1 is 3. So it looks like it base 5. 1, 1, 1 is, but this is a reminder. So this is not entirely base 5 because we didn't change. So the 2 is like too little for 1, 1, 1. The 1, 1, 1 is 7, and in the base 5 it is 12. So we actually write only the last digit. And what if we do it like this? Yeah, of course it is like modulo operation. Okay, I think to convert to the base 5 you have to actually do the sum of the previous result. Okay, that's all. Let's look at hint. It's kind of not trivial, and acceptance rate is pretty low for the easy problem. I wonder if anyone mentioned the base 5. Okay, I will research it later. Now you can watch how I solved this problem in 6 minutes.